This video will explain how to do a problem like this. I'm going to go much faster than I would in a classroom because you can pause it anytime you need to, and you should do that. So, first, what is a series? Well, here are some examples of series. Again, pause the video, look at them, and see if you can figure out what makes something a series. Of course, I've written it at the bottom there. So what makes something a series is numbers separated by plus signs and with a pattern. There has to be a pattern to the numbers. Series can end like this one has 5 terms, 1, 2, 3, 4, 5. Or if we write plus ... it means we understand that we can write as many terms as we want following the same pattern. So for this series, for example, each one you're adding 3. For each term you're adding 3 to the term that came before, and we could do that forever. So it has a pattern, so we could write as many terms as we need to. Okay. This symbol was in the original problem, a capital S with a little subscript n. What does that mean? It means the sum of the first n terms. So let's do an example to explain that. Here's the series we had before. Okay. And I could even write plus ... to get you to start thinking that the series can have as many terms as we want. S1 would mean add up all the terms going up to the first term. So that's just 1. Okay. S2 means add up the first 2 terms. So that's 1 plus 4. That's 5. S3 means add up the first 3 terms. So that's 12. S4 would be 1 plus 4 plus 7 plus 10. So that'd be 22. And S5 would be the first 5 terms added together. So that would be 35. So that's what capital SN means. We'll come back to that. We'll use that again later. Okay. Here's a second example. This series 1 plus 10 plus 100 plus 1,000 plus 10,000. Okay, there's clearly there are terms divided by or separated by plus signs, and there's clearly a pattern to it. Okay. S1 means just the first term by itself. S2 means the sum of the first 2 terms. That'd be 11. 1 plus 10. S3 means the sum of the first 3 terms. S4 would be, S5 would be. Okay. So now you can see the advantage we can take of there being a pattern with this optional question. What if this series goes on as many terms as we need? That's what the plus ... means. It means we can write as many terms as we need, and someone asks you for S12. You don't have to actually write out the first 12 terms and get a calculator and add them all up, because you can see the pattern. S3 had 3 ones, S4 had 4 ones, so S12 has 12 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we could put commas to separate them. So millions, 111 billion, and so forth. Okay? All right, so the original question did not just ask about series, it asked about geometric series. So now we'll look at what is a geometric series. What does it mean to say a series is geometric? None of those series I showed you before none of the first 2 series were geometric. The third one was, but none of the first ones were. The first 2 were not. So geometric series is a special type of series. Here are 4 examples of a geometric series. You should pause the video and see if you can figure out what the pattern is, and see if you could predict the next term for each one. Okay? All right, the pattern is that we're not always adding the same number to get the next term, right? Clearly we add 1, then we add 2, then we add 4, then we nope. So we're not adding the same number, we're subtracting. What we're always doing is multiplying a term to get the next term. We're always multiplying by the same number. And the first one, it's 2. So this is times 2. 2 times 2 is 4. 2 times 4 is 8. And 2 times 8 is 16. And with that, you could predict that the next term is 32. Pause the video and see if now you can figure out what the multiplier is for each of these 3 and figure out what the next term would be. Okay? The multiplier for this one is 3. Okay? And the next term would be 3 times 81, 243. The multiplier number for this one is clearly times 4. I've made easy geometric series here so you can spot the multiplier. Then we'll learn how to figure out the multiplier if they're not so easy. Okay, and the next term would be 4 times 64, which would be what, 256? Okay. And then the multiplier here, you might think it's 10. It's not 10. If you thought it was 10, pause for a minute and figure out what the multiplier would be. What do you have to multiply each term by to get the next term? And the answer is 2. The multiplier is 2. Okay, so here's the definition, the official definition of when a series is geometric. Definition of a geometric series. If you take any term in the series and divide it by the term that comes immediately before it, you always get the same number. So in our first example, if we take this term and divide it by the one that came before, we get 2. If we take 4 and divide it by 2, we get 2. If we take 8 and divide it by the term that came before, which is 4, 8 over 4 is 2. We always get the same number when we take a term and divide it by the one before. Okay? That number, since you're doing a division, and that can be called a ratio, that number is called the ratio, and the letter we use for it is R, which was in our original problem. So now we've learned what capital S with a little n means. You call that S sub n. That's the nth sum, and then, or partial sum, nth partial sum, and now we've learned what R means. It means that ratio. Okay? All right, so figure out what R is for each geometric series. Again, pause the video and do it on your own because I'm immediately going to write the answers. For this one, it's 2, because 2 over 1, 4 over 2, 8 over 4, and 16 over 8 all equal that ratio of 2. Okay? Again, pause the video, try these on your own, and I'm just going to write what they are. This one's 3, this one's 4, and this one's 2.5. And you may think, well, I just have to look at that. That's all I have to look at. No, because it could be trying to trick you by making these terms not geometric. The first two, you could start with 1 and 3, and even 1, 3, and 9, that doesn't mean they're all going to be correct. So to actually be sure, you'd have to take 15.625 and divide it by 6.25, and you get this number, this ratio 2.5. For any pair that you try, a number divided by the one before it, you'll always get 2.5. So R equals 2.5 for that one, R equals 4, R equals 3. Okay, to give you some practice, look at these. Again, pause the video, try them on your own. And I'm going to immediately do them. So they give you R, and they want you to write the simple geometric series. Okay, always starts with 1 plus 2 plus 2 squared plus 2 to the third, and they want 5 terms. Okay, 1, 2, 3, 4 to the fourth. Okay, and if we needed to simplify it, we'd write it like this. And if we needed to figure out the sum of the first 5 terms, write big S for sum, little 5, meaning we want sum of the first 5 terms, we would add those all up. Okay? All right, let's try this one. 1 plus 10 squared plus 10 cubed plus 10 to the fourth plus 10 to the fifth. 1, 2, 3, 4, 5, 6. I've written 6 terms. And if I wanted the sixth partial sum, S sub 6, sum, the sixth term sum, I'd add all those up. And that's pretty easy to see what that would be. We've seen this series before. Plus 1,000, plus, etc. Okay, so in general, the simplest kind of geometric series you can have, they give you an R, and you just follow this pattern. 1 plus R squared plus R cubed plus R to the fourth, and then you just keep increasing the exponent by 1 for however many terms you need. But you can also get a geometric series if you multiply every term by the same number. And we saw one of those near the beginning, the one that began with 10 instead of 1. We can multiply them all by the same number and you still get a geometric series. So let's look at an example of that. Example is the ratio, that base, is R equals 2. And that gives us that familiar series we've seen so many times now. Okay. Now, try multiplying every single term by the same number. We'll use 10 because it's so easy. Multiply every term by 10. Then you get this series in green. Okay, you say, wait, I'm not sure that doesn't begin with a 1. How do I know it's still geometric? You do that division thing. You divide every term by the term before it. So 20 over 10, 40 over 20, 80 over 40, 160 over 80. Do we always get the same number? Yes, it's 2, which means R equals 2. Okay, so it's still geometric because it meets that definition that every term divided by the term before it gives us the same number. Okay? The other way of saying that is if you take a term and multiply it you always, to get the next term, you always multiply it by the same number. It's just the other side of the mirror. Multiply it by 2. Always get the same number. So it's geometric. So we can create a geometric series by starting with a base, a ratio, writing out the series, and then multiplying every term by the same number. As long as we multiply every term, here it was 10. Okay, of course, mathematicians have a symbol they use for this number. They call it a sub 1. Or, actually probably more commonly, a. But the problem I was asked to do had a sub 1 instead of a. We call this multiplier number a sub 1. So now we have the general formula for any geometric series. 1 plus r squared plus r cubed plus r to the fourth plus keep increasing the exponent by 1 however many you need. And then we can multiply them all by the same number. Okay, let's put it all together and do some example problems so you can see how this fits. So in this, again, the best thing for you to do is to pause it, try this on your own, and then compare it with what I do. They give you the R and the A1, and then they ask you to find S sub n if n equals 4. So we have to tie together everything we've done. Okay, S sub n if n equals 4. They're just telling you n equals 4, so I can write S sub 4. That means I want the sum. Again, you should pause and see if you remember what that means. That means I want the sum of the first 4 terms. So I have to write out the first 4 terms of the series. And in general, every geometric series can be written as a1 times 1 plus r plus r squared plus r cubed. How many should I do until I've reached 4 terms? 4. Okay, 4 terms. 1, 2, 3, 4. Okay, now let's plug in. So that's the general formula they want me to do because they want the sum of the first 4 terms. Now let's plug in what they gave me. They did not give me the sum of the first 4 terms, but they did give me a1, 10, and then they gave me r. Okay, let's see what that is. And again, you should do this on your own. Okay, so this is 8 plus 4 plus 2 plus 1 times 10. Okay, so 15, right? 8 plus 2 is 10, 15 times 10. Oh, good. Okay, so that's nice and easy. 150. The sum of the first 4 terms equals 150. That's the answer. This is called the fourth partial sum. It's called a partial sum because we could have gotten more. All right, let's try another one. Pause the video, try it on your own. I'm going to go faster this time. Wow, that was fast. Oops, I know I made a mistake, sorry. Plus 25 plus 125. Okay, see what I did? 1 plus 5 squared plus 5 cubed. 4 terms, 1, 2, 3, 4. All right, and the multiplier out front is a 2. All right, so let's add these up. 125 plus 5 plus 25 is 150. 155, 156. S4 equals, what is that, 312? Looks like 312. Okay. All right, finally, our last example before we go back to the original problem. This one's a little backwards. This time they give us the partial sum, and they ask us to find that multiplying coefficient out front. But it's still the same pattern. Sn equals a1 times 1 plus r squared plus r cubed plus however many you need. Okay, and they tell us n equals 3. This can be confusing because it seems like you have 2 unknowns here, s and n, but they tell you what n is. So write s3 equals. a1 is the thing we don't know, so we have to leave that as a letter. R is 2, and I want 3 terms, because they say n equals 3. I want 3 terms. 1 plus 2 plus 2 squared, and that's it. All right, and let's plug in, I already plugged in there, but I'll plug in the other one. Plug in S3 is 35 equals A1 times, and then this is not too hard to figure out, that's 7, and so A1 equals 5. All right, and then finally we come to the problem at the very beginning of the video. These numbers are trickier. that is a bigger sum. That's an R with a decimal value. So I'm not going to really do that by hand. Right? It's just like the previous problem, except the numbers are more difficult to do by hand. So for this, you would use a calculator. All right, let's do this problem. As always, Sn equals A1, that multiplier out front, plus 1 plus R squared plus ... however many we need. Okay, and let's plug in. Let's see, they say n equals 4. So I want S4 equals A1 is the unknown, so I'm going to leave that as a letter. R is 4.5, and I'm going up to 4 terms. So 1 plus 4.5 plus 4.5 squared plus 4.5 cubed. You can see this is a job for a calculator. This was given as 6545. And if you put this in a calculator and simplify it all out, you get 116.875. Right? And even if you just have a handheld calculator, you can still figure this out by just multiplying 4.5 times 4.5 times 4.5, writing it down, adding them all together. All right, and then the last step is simple. Just divide this by this, and you get A1 equals 56.